Hello students, I am Renu Matthew, Assistant Professor, MC Department, IISM Pune. In this lecture, let us see what is integration testing. Integration testing is a level of software testing where individual units are combined and tested to verify if they are working as they intend to when integrated. The main aim here is to test the interface between the modules. Just unit testing is not enough for multiple reasons, like a module or a unit is usually designed by an individual software developer whose techniques and programming logic differs from that of other programmers. So when integrating, it may create problems. It may happen that the user requirements change and these new requirements may not be unit tested, which instigates issues in the system. Issues like data formatting, error trapping, hardware interfaces, and third-party service interfaces are sometimes missed during unit testing. So no matter how efficiently each module or unit is tested, if they aren't properly integrated, it will affect the functionality of the software program. As a solution, integration testing is implemented. So in integration testing, we test interfaces between components, interactions between different parts of the system, such as the OS, file system, and hardware, or interface between systems are tested. The test bases are software and system design, both high-level design and low-level design, system architecture, and it can be the use cases also. In integration testing, individual software modules are integrated logically and tested as a group. So it is also termed as integration and testing, that is INT, sometimes called as string testing or thread testing. Again, there are levels of integration testing, component level testing and system level integration testing. Component integration testing tests the interface between software component and it is done after component testing is performed. In iterative and incremental development, component integration tests are usually part of a continuous integration process. System integration testing can also cover interactions with and interfaces provided by external organizations like web services. System integration testing is done after the system testing. Sometimes it may happen that the developing organization does not control the external interfaces, which can create various challenges for testing. For example, ensuring that test blocking defects in the external organization's code are resolved, arranging for test environments, etc. So in this case, system integration testing will be helpful. The objectives of integration testing are reducing the risk of having defects in the application, verifying whether the functional and non-functional behaviors of the interfaces are as defined and specified. Of course, building confidence in the quality of the interfaces, finding defects which may be in the interface themselves or within the components or systems, and preventing defects from escaping to the higher levels of testing, that is to the system testing level or to the acceptance testing level. Performing integration testing offers a lot of benefits. Some of them are: it makes sure that the integrated modules work properly as intended. It detects errors related to the interface between modules. Help modules interact with APIs and other third-party tools. It typically covers a large volume of the system, so it is more efficient. It increases the test coverage and improves the reliability of tests. The test basis for integration testing are software and system design, sequence diagrams, interface and communication protocol specifications, use cases, architecture at component or system level, workflows, external interface definitions. And the test objects will be the subsystems, the databases, infrastructure, interfaces, APIs, and microservices. Typical defects and failures identified in integration testing are incorrect data, missing data, or incorrect data encoding, incorrect sequencing or timing of interface calls, interface mismatch, failures in communication between components, improperly handled communication failures between components, failure to comply with mandatory security regulations when we are using third-party software and which are integrated to the system. Now let's see the types of integration testing. It can be incremental or non-incremental. Under incremental type, we have the top-down, bottom-up, and hybrid approach, whereas Big Bang is a non-incremental approach. In Big Bang approach, we put all the components in one go for integration testing. All components or modules are integrated simultaneously, after which everything is tested as a whole. As per the image given here in the slide, all the modules from module 1 to module 6 are integrated simultaneously and then the testing is carried out. The advantage is that it is very convenient way of integration testing for small systems. And everything is finished before integration testing starts, like all the units will be tested before you start with the integration testing. And the disadvantages are fault localization is very difficult when we are going for Big Bang approach. Since all modules are tested at once, high risk critical modules are not maybe isolated and tested on priority. Peripheral modules which deal with user interfaces are also not isolated and tested on priority. In the incremental approach, testing is done by joining two or more modules that are logically related. So while testing, sometimes we face a situation where some of the modules are still under development. These modules or testing purpose are replaced with some dummy programs, and these dummy programs are called as stubs and drivers. The top-down approach starts by testing the topmost modules and gradually moving down to the lowest set of modules one by one. Testing takes place from top to down following the control flow of the system. As there is a possibility that the lower level modules might not have been developed while top modules are tested, we use stubs instead of those not ready modules. For simple applications, stubs would be simply return the control to their superior modules. For complex applications, they would simulate the full range of responses. The advantages are fault localization is easier, the test product is extremely consistent, the stubs can be written in lesser time compared to drivers, critical modules are tested on priority, major design flaws are detected as early as possible. And the disadvantages are basic functionality is tested at the end of the cycle, sometimes requires several steps to be used for integration testing, and poor support for early release. Bottom-up integration testing. The bottom-up integration approach starts with testing the lowest units of the application and gradually moving up one by one. Here testing takes place from the bottom of the control flow to upward direction. Again, it is possible that the higher level modules might not have been developed by the time lower modules are tested. In such cases, we simulate the functionality of missing modules by using drivers. These drivers perform a range of tasks such as invoking modules under test, pass test data, or receive output data. The advantages are here development and testing can be done together, so the product will be efficient. Test conditions are much easier to create, and the disadvantages are it requires several drivers, data flow is tested very late, need for drivers complicates test data management, poor support for early release like how it is in a top-down approach. Key interface defects are detected late in integration testing. Hybrid or sandwich integration testing. To overcome the limitations and to exploit the advantages of top-down and bottom-up approaches, a hybrid approach of integration testing is used. This approach is known as sandwich integration testing or mixed integration testing. Here, the system is viewed as three layers. Main target layer in the middle, another layer above the target layer, and the last layer below the target layer. Top-down approach is used on the layer from the top to the middle layer. Bottom-up approach is used on the layer from the bottom to middle layer. And Big Bang approach is used for modules which are there on the middle layer. The advantages are top-down and bottom-up testing techniques can be performed in parallel or one after the other. Very useful for large enterprises and huge projects that further have several sub-projects. It takes less time to complete testing. Integration is done when modules are implemented, and it helps to test the modules interface very faster. The disadvantages are the cost requirement is very high. It can be more complicated to test. In this approach, it is very difficult to localize the faults. This approach is not suitable if the projects are very small. So these approaches that you use to perform integration testing is based on your testing requirements. You should check which testing strategy can be adopted and prepare the test data and test plan accordingly. The challenges of integration testing are managing integration testing is difficult sometimes because of various factors like database, platform, the environment, etc. Integrating a new system to a legacy system or integrating two legacy systems needs a lot of testing efforts and changes. Less compatibility between the two systems developed by the two different companies is a challenge for programmers. There are way too many different paths and permutations to apply for testing the integrated systems. Despite these challenges, integration testing is very useful in the software testing process. It is an important part of the testing cycle that makes it easy finding defects when two or more units are integrated. So with this, we come to the end of this lecture. Stay tuned. Thank you.